Good morning, sir. Good morning to everyone. This is Sumitra from CSE. Today's topic is backtracking. Introduction to backtracking. Backtracking is an algorithmic technique for solving the problems incrementally. It builds candidates for solutions and the candidates that fails to satisfy the conditions of the problem. This method is particularly useful for combination problems where a solution may not be easily derived. How backtracking works. The process involves building a solution incrementally and making decisions at each step. If a partial solution fails to satisfy the problem's constraints, the algorithm backtracks to the previous step. This continues until all possible candidates are explored or a valid solution is found. Key concepts in backtracking. State space trees is a conceptual tool used to represent all possible states in a backtracking problem. Constraints to determine the validity of a solution and guides the backtracking process. Running in the techniques used to eliminate the large positions of the search space and making the process more efficient. Common use cases. Double tap to text. Backtracking is widely used in solving puzzles like Sudoku and crosswords. It is also applied in combinational optimistic problems like an n-queens problems. Additionally, backtracking is used for generating the permutations and combinations of a set. NQs problems. The NQs problems involve spacing NQs in an n cross n chessboard so that no two queens threaten each other. Backtracking is employed to space queens one row at a time, checking for validity at each time. This problem, the efficiency backtracking in finding all the possible arrangement. Sudoku is an number puzzle that requires filling a grid with digits while specific rules. Backtracking helps to filling the grid by trying numbers and converting when a conflict arises. This approach ensures that all potential configurations are explored until a solution is reached. Pros and cons of backtracking. Backtracking is straightforward to implement and understand, making it acceptable for beginners. However, it can be insufficient for the problems with large search spaces due to the exhaustive nature. Optimizations like constrict program propagation and methods can enhance its performance. Backtracking versus other techniques. Unlike dynamic programming, backtracking traits all possible without storing intermediate result. Compared to greedy algorithms, backtracking does not make irreversible decisions at each step. It provides a more through search methods, which can be essential in finding all the solutions. Greedy methods versus dynamic programming. Greedy method, dynamic programming. An algorithm that follows the problem solving of making the locality optional choice. Each stores with the finding a global optimization. Dynamic programming. An algorithm that helps to efficiently to solve the class of problems that have overlapping subproblems and optimal substructures properly. Less sufficient, and in dynamic programming more sufficient. Greedy method. First makes a choice that looks best at the time and then solves a resulting subproblem. Solves all the subproblems and then select one that helps to find the optimal solution. Makes decision considering the first stage. Makes decisions at every stage. Implementation of backtracking. Backtracking can be implemented using recursion or iterative methods with a stack. Recursive implementation are more common and often cleaner code for complex problems. The choice of data structure impacts the sufficiency and clarity to the backtracking algorithms. Conclusion and future directions. Backtracking remains a fundamental technique in an computer science for solving complex problems. Future research may focus on hybrid methods combining backtracking with other algorithms for improved sufficiently. Understanding backtracking is essential for algorithm enthusiasts and professional alike. Thank you.